Ions and isotopes. When an atom or molecule loses or gains one or more electrons, it becomes an ion. The losing of an electron would always result in an overall net positive charge, and the gaining of an electron would result in an overall net negative charge. Metals are elements in the periodic table that lose electrons from their outermost shell to form positively charged ions, sometimes referred to as cations or cations, depending on your pronunciation. So in a positive ion, there will be an unbalance of charges. 3 protons and 2 electrons will give you a net positive charge. So in this case, the figure represents a +1 ion. Non-metals are elements on our periodic table that gain electrons in their most outer shell to form negatively charged ions called anions. The figure represents a negative ion, and again, as you can see, an imbalance of charges as a result of 2 protons and 3 electrons would result in a -1 charge. All atoms of the same element have the same number of protons and therefore the same atomic number. They can, however, have different number of neutrons. A typical example is hydrogen. There are 3 known isotopes of hydrogen. You can have hydrogen with just 1 neutron, you can have hydrogen with 2 neutrons, or you can have hydrogen with no neutrons. They're all hydrogen, but they have different number of neutrons and therefore different relative atomic masses. They are called isotopes. Isotopes are atoms of the same element with different number of neutrons. The 3 isotopes of hydrogen are protium, deuterium, and tritium. They all have symbols of hydrogen H and therefore have exactly the same atomic number. However, protium has no neutron and therefore has a relative atomic mass of 1. Deuterium has a nucleus with 1 proton and 1 neutron, so therefore has a relative atomic mass of 2. Tritium has a nucleus with 1 proton and 2 neutrons, therefore has a relative atomic mass of 3.